Pallavi Sharma from Galgotia University. I am teaching you here climate and architecture, and this is a part of your module climate responsive architecture. So let's begin with the lecture. Let's discuss what are the contents we are going to study in this lecture. We are going to study the climate and architecture, how climate is related to architecture, how architecture is related to climate, and what is the role of climate in architecture. Climate plays a very important role in architecture. In our presentation, we will see how climate affect the climate, or how architecture affect the climate, and how climate affect the architecture of a particular region. And finally, we talk about the factors affecting the climate. Briefly, we talk about firstly climate and architecture, then we will discuss in detail the factors affecting climate. Start with climate and architecture. We all hear about the weather and the climate all of the time. Most of us check us local weather forecast to plan our days, and climate change is certainly hot topic in the news. Here there is, however, still a lot of confusion over the difference between the two. Now let's discuss the weather first. The weather is a phrase represent the state of atmospheric environment over a brief period over time, whereas climate is a weather condition over several years is generally referred to as climate. Means weather is a short-term condition of the atmosphere, while climate is the average daily weather for an extended period of time. I think they have think about in this way: climate is what you expect, weather is what you get. Okay, think about in this way: climate is what you expect, while weather is what you get. This is the thing in which you will be able to categorize the two things. Climate is the average of that weather. For example, you can expect snow in northeast in January, for it to be hot and humid in southeast in July. This is climate. The climate record also includes extreme values such as record high temperatures or record of high or low rainfalls. If you ever heard of local weather, person say today we hit a record high for this day, we hit a record low for this day, she is talking about the climate records. Okay, so when we are talking about climate change, we are talking about the changes in a long term averages of a daily weather. In most places, weather can change from minute to minute, hour to hour, day to day, season to season. Climate, however, is the average weather over a time and space. The information helps designer to build a house that filters out adverse climatic effects while simultaneously allowing those that are beneficial. The build form and arrangement of the openings of a building can be suitably derived from this analysis. Climate thus play a pivotal role in determining design and architectural features of building. Role of climate in architecture. Climate plays a very important role in architecture and building forms. The comparison of climate data and requirements of thermal comfort provides the basic selection of building form and building elements appropriate for the climate so as to create necessary internal comfort. Efforts are made here to present specific design in major climates. Everybody is seeing this picture in this slide. These architecture style. I think all of you will guess this is from India, and from which part of India. Wow, why? The architecture style of Rajasthan is like that due to the climate of that region. A water body is placed. Why the water body is placed um, in front of the building? To cool down the air, to make the flow of air proper. So climate is a particular produces certain easily observed effect on architectural form. For example, the proportion of window area to wall area becomes less as one moves towards the equator. In warm areas, people shun the glare and heat of the sun, as demonstrated by the decreasing size of windows. In subtropical and tropical zone, more distinctive changes in architectural form occur to meet the problem caused by excessive heat. In Egypt, if we talk about Egypt, Iran, Pakistan, deep rovers, projecting balconies and overhang casting along shadows on the walls of building are found. Wood and marble lattices fill large openings to substitute the glare of sun while permitting the breeze to pass through. Such arrangements characterize the architecture of hot zones and evoke comfort as well as aesthetic. With the visible endeavors of man protect himself against the excessive heat, today a great variety of devices such as sunbreakers, bright soil have been added to the vocabulary of architecture features in these zones. Notice to how to I think maybe you notice to the gabled roof decrease in pitch as the rate of precipitation decreases. In northern Europe, the most distinct districts subject to heavy snow, gables are steep, while in the sunnier lands of the south, the pitch steadily decreases. All these factors combinedly, the architecture style of the regions combinedly affected from the climate only, and we have to design according to climate, otherwise we can't survive in this in that design. Internal comfort, why should we design? We are designing for our comfort, for to make our life easier, to make our life comfortable. If we don't design according to the climate, we will not able to achieve that comfort. So according so climate and architecture runs simultaneously. Now what are the factors that affect the climate? Earth is a dynamic planet constantly undergoing changes driven by internal and external forces. Currents of magma with our planet move to the plate that form the continents, and in a constant process, it is a constant process, and builds mountains, creates valleys. The valleys may eventually become lakes, seas, and oceans. On the surface, the greatest factor affecting Earth is sunlight. Sun provides energy for living organisms, and it drives our planet weather and climate by creating temperature gradients in atmosphere and in the ocean. So major factor affecting the climates are solar radiations, ambient temperatures, air humidity, precipitation is the amount of rainfall which is received by a particular region, wind, sky condition, whether it is cloudy or hazy or clear, and the corresponding and the vegetation. So due to all these guiding factors for the role of climate in architecture, we have to study the subject in architecture, that is climatology, and it is a major main part of your design related subjects. Climatology is a basic thing you have to follow until your last year of the architecture, or till the last year of your practice. So by this medium of this video, we will discuss what is climatology. What is climatology? Climatology is a scientific study of a climate. It is a branch of physical geography in which we study systematic and scientific approaches of climatic variation and interaction with biosphere, lithosphere, atmosphere, and hydrosphere. Climate, the long-term condition of atmosphere, I already told you. Weather, the short-term condition of atmosphere. Elements and factors of weather are, we already discussed. Temperatures is how hot, what is driven by how hot or how cold, how many degree it is above or how many degree it is below freezing. And humidity is the amount of water vapor. Precipitation is a product of rapid condensation process or rainfall. Atmospheric pressure is the weight of air resting on the earth's surface. Wind, the movement of air masses, especially on the earth's surface. Factors affecting the climate. We have discussed about the factors affecting the weather, and now factors affecting the climate. Distance from the sea, ocean currents, the direction of prevailing winds, the shape of land known as relief or topography, distance from the equator, human activities, branches of these are the major things which affect the climate of a region. Branches of climatology are physical climatology. The brief introduction of the branches. We need not to go in detail, but you have to know the branches. Regional climatology, applied climatology. Some of the other branches of climatologies are microclimate, which gain popularity right now in time. Geoclimate, etc. So now we are clear with what is climate and what are the factors affecting the climate, what are the factors affecting weather, and what is climatology. Why should we study climatology and the branches of climatology? The first factor which affect the weather of a particular region is a solar radiation. Solar radiation is a radiant energy received from the sun, often called solar resource or just sunlight, is a general term for the electromagnetic radiation emitted by the sun. Solar radiation can be captured and turned into useful forms of energy such as heat, electricity using a various technologies. However, the technical feasibility, economical operation of these technologies at specific location depends on the availability of solar resources. Basic principle of receiving solar energy. Every location of Earth receives sunlight at the least part of the year. The amount of solar radiation that reaches at any one spot of the Earth's surface varies according to their geographical location, time of the day, season, local landscape, and local weather. Radiation is the radiant energy received from the sun. It is the intensity of sun rays falling per unit time per unit area and is usually expressed in watts per square meter. The radiation incident on a surface varies from moment to moment depending on its geographical location, orientation, seasons, time of the day, and atmospheric condition. Solar radiation is one of the most important weather variable that determines whether a place experiences high or low temperature. The instrument used are pyranometer, pyrheliometer to measure sunshine. Because the earth is round, the sun strikes surface at different angles, ranging from 0 to 90. When the sun rays are vertical, the earth gets all energy possible. The more slanted the sun rays, the longer they travel through atmosphere, becoming more scattered and diffuse. Because the earth is round, the frigid polar regions have never get a high sun, and because of tilted axis of rotation, these areas receive no sun at all during part of the year. As you all know, the earth revolves around the sun in an elliptical orbit and is closer to sun during the part of year. When the sun is near the earth's surface receives a little more solar energy. The earth is near the sun when it is summer in the southern hemisphere and in winter in northern hemisphere. However, the presence of vast oceans moderates the hotter summers and the colder winters one would expect to see in the southern hemisphere as a result of these differences. In this picture, you see how architecture is modified according to the solar radiations. In this, if you plant solar panels on roof, so you have to position the building accordingly. If you want to block the sun and if you want to less diffuse solar radiation or filter solar radiation, you have to plant the trees. So solar radiation is major guiding principle for architecture to design. Countries such as United States, which is in the middle latitude, receives more solar energy in the summers. Not only because days are longer, but also because the sun is nearly overhead. The sun rays are more slanted during the shorter days of winter months, and cities such as Denver, Colorado, three times more solar energy in June than they do in December. The rotation of Earth is also responsible for hourly variation in sunlight in the morning and the late afternoon. The sun is low in the sky if rays travel further through the atmosphere than at noon, when the sun is at highest point. On a clear day, the greatest amount of solar energy reaches a solar collector around solar node. Now, the effect of orientation. Most of the times when sun and architecture are placed in similar context, things that come first in people's mind in high technology and glass skyscrapers, the most need of natural light and energy appeared in public edifices by reason of using too much energy for basic need in a building. Architects and engineers found alternative eco-friendly solution that can be used in both private and public spaces. As a consequence, in some parts of world, people and designers raise the question how to use much sun as possible without spending money. The answer stood simplicity and appeared soon after the question. Ancient solution applied to a new modern strategic solar building orientation. As every fact has advantage and disadvantage, orientation of house towards sun becomes beneficial, benefited and weakness both. As the disadvantage make people take a second thought before making a decision. Therefore, in this situation, designer trying to find a balance between pluses and minuses, the optimal solution that they try to reach to use weakness in their favor. As a result, they are working innovative and cleverly in a building design process in order to achieve energy efficiency. Now, the effect of sky cover in getting solar radiation. Example: Mumbai is cool in the month of August due to presence of clouds and rainfall. But in our northern part, we are not in cool atmosphere. We are receives high amount of heat. Direct sunlight in summer, diffuse sunlights in summer due to presence of high clouds. Basically, at night, cloud cover has the opposite effect. If skies are clear, heat emitted from the Earth's surface freely escape into space, resulting in colder temperatures. However, if the clouds are present, some of the heat emitted from the Earth's surface is trapped by clouds and re-emitted back towards the sun. So, it functions on both the ways. Effect of time on solar radiation. On afternoon, we received direct sunlight. The hotter the sun, we get more and more sun rays, and we feel very hot. At noon, at noon or after when sun rays are slanting, we receive smaller amount of radiations. So solar effect of time, the timing of the sun position is also affect the solar radiation we get on the earth. Now start with the second factor, that is ambient temperature. The temperature of air in a shaded but well ventilated enclosure is known as ambient temperature. Ambient temperature is the average temperature surrounding something, whether inside or outside. In relation to weather, the ambient temperature is same as the current temperature at any location. It is generally expressed in degrees Celsius. Temperature at given site depend on wind as well as local factors such as shading, presence of water body, sunny location, etc. You in this These two figures are here to show to understand you the role of trees and how trees regulate the ambient temperature of the particular area. Deciduous tree provide shade in summer to allow sunlight in winter, because already you all know deciduous trees shed their leaves in winter season. That season is called Patjhad, and allow the sun to enter in the building. Whereas in contrast, in summers the tree have fully grown and fully covered with leaves, so it blocks the sun, summer sun or unwanted sun. Next example is pools and fountains at Fatehpur Sikri used for cooling Diwane Khas. If you put a water body along the wind direction, it definitely cools the hot air and supply the cool air after passing from it. It also regulates the ambient temperatures of a particular area. So you can see how the architecture is molding or modified by the weather condition or climatic condition of a region. Next factor, that is air humidity. Humidity is a major play a major role in comfort or discomfort in insects. If the temperature is low but the air is humid and humidity at high level, you definitely feel much more discomfort due to humidity rather than the temperature. You all know how the in our region, if we are living in North Delhi NCR region, how the August weather and how the June weathers are related. In August, the temperatures are low, but the humidity is high, and the amount of discomfort we feel is very much higher. What is now air humidity? Air humidity, which represents the amount of moisture present in the air. High humidity accompanied by high ambient temperature causes a lot of discomfort. As I told you, humidity is the amount of water vapor. Basically, what is air humidity? Is the amount of water vapor in the air. If there is a lot of water vapor in the air, the humidity will be high. The higher the humidity, the wetter it feels outside. On the weather reports, generally humidity is usually explained as relative humidity. What is this? This relative humidity is the amount of water vapor actually in the air, expressed as a percentage of maximum amount of wet water vapor of the air can hold at a same temperature. Think of the air at a chilly -10 degrees Celsius, and that temperature the air can hold at most 2.2 grams of water per cubic meter. So if there are 2.2 grams of water per cubic meter, when it's -10 degrees Celsius outside, we are in uncomfortable 100% relative humidity. If there was 1.1 grams of water in the air, -10 degrees Celsius, we are at the 50% of the relative humidity. So discomfort level is determined by the amount of water vapor or relative humidity of our air at a particular time, and according to the how much air can hold the capacity, how hold the air humidity at a particular temperature. Now, precipitation. The definition of precipitation is any form of water, liquid or solid, falling from the sky. Precipitation includes water in all its form, rain, snow, hail or dew. It is usually measured in millimeters and it is measured by using rain gauge. More precipitation or these things also determining the weather conditions, factors which determine the weather condition of a particular region. Now another factor is wind. Wind is the movement of air due to difference in atmospheric pressure. Wind speed can be measured by the instrument called anemometer, or it is expressed in meters per second. It is a major design consideration for architects because it affects indoor comfort condition by influencing the conceived heat exchanges of a building envelope as well as accusing air infiltration into the building. You can see how the factor affecting the wind. We have to place our building in the prevailing wind direction. What are the prevailing winds? Prevailing winds are the winds which blow almost half of the year, more than 6 months of the year, because wind changes its direction by season to season. But we took consideration the prevailing winds of the year because the direction changes by season to season. In monsoon season we receive easterly winds also. In winter we receive westerly also. We can't design according to every direction of the wind, so we will take the prevailing wind directions in our design. So it is also a most important factor of architects to design ventilation, to design fenestration in a building. Comes to sky condition. Sky condition generally refers to the extent of cloud cover in sky or the duration of the sunshine. Under clear sky condition, the intensity of solar radiation increases where as it reduces in monsoon due to cloud cover. So cloud cover affect the building, cloud cover affect the clear sky, we amount less radiation, so temperature will be less. So sky condition also matters in determining the weather of a particular region. Now comes to temperature. Temperature is a physical quantity that expresses the subjective perception of hot or cold. Temperature is measured with thermometer, historically calibrated in various temperature scales and units of measurement. The most commonly used scales are Celsius, Fahrenheit and Kelvin scale. Temperature, you all know, we all daily check the temperature of our area, how the cold is that, how the hot is that. In winters, we check how the minimum, in summers, we check how the maximum. Temperature is the degree of hotness or coldness in a particular region at a particular time. Vegetation also plays an important role in determining the microclimatic condition of a particular region. More the vegetation, clear microclimate is colder because evapotranspiration increases, air breezes increases. Trees help us to regulate microclimatic condition. Around the tree, the temperatures are low. More amount is evapotranspirated, so the temperature will be low and a comfortable condition in a hot weather. Comfortable condition is will be achieved by planting more trees or at planting more trees and design according to trees. Plants are also used for climate control. For climate control, deciduous trees, shade trees might used to be screen the hot summer sun, or in winter permit the solar radiation. I have already shown you that this type of image in previous slide also. Radiation. Winter permit the solar radiation to penetrate to the ground or to the walls, windows and the building. Large shrubs can serve as a windbreaks to reduce wind velocities. Changes solar radiation or light levels are also possible with the shading. Many type of the function which is performed by trees for climate control. We will discuss it in detail in another lecture. So this is a brief how the trees affect the microclimate, or it regulates the climate. It reduces the pollution, it reduces the noise pollution, it purifies the air, it gives a fresh feel to us. So trees are basically lungs of the city. Without vegetation, we can't survive. To these factors, number of natural elements such as hills, valleys, water bodies, etc. affect the climate locally. Buildings, cities, and other man-made features also have an important on the climatic condition. Assignment for you is the different. What are the different factors affecting the climate? Explain with the neat sketches of measuring instrument and measuring unit is these elements. You. Let's meet in another class of climate responsive architecture. I think all of you have studied the things which are responsible for climate and weather conditions. What are the role of climates? How climate is important in architecture, and what are the factors affecting the climate? We had studied in this presentation these things, and progress will be studied in the next lecture. Thank you.